This video showcases a few examples of smart learning content designed to help effectively teach the Python programming language. These have been deployed through the Mastery Grids interface, developed by the PAWS Lab out of the University of Pittsburgh. On screen is an actual example of a Python course that was run for a classroom of students through the Mastery Grids system. Under Variables and Operations, we can see 35 problems covering varying levels of knowledge and expertise within this particular topic. I've completed most of these examples already, but we can revisit an animated example introducing the fundamental notion of variable assignation in Python. In animated examples, the content is split between a block of code on the left and a moment-to-moment depiction of the stack and terminal output on the right. Using the controls along the bottom, a student can progress, rewind, start over, and step through the animation piece by piece. Each step of the way, the line of code being currently executed is highlighted and indicated with an arrow. A textual description of the current step displays above the animation controls for added clarity, and we can proceed with the animation until the supplied code completes, and in this instance, our assigned variable has the last of its assigned values printed to the simulated terminal. When there is nothing left for the user to see, the exercise is considered complete. They can continue to review it as long as they'd like, or close out of it and return later if they ever feel the need. Next, we'll take a look at the Boolean expressions concept area, and move on from animated examples to instead review a program construction example, or PCEX. You'll notice that I happen to have two separate listings for these, PCEX examples and PCEX challenges. Differences between the two are minor, and mostly pertain to the amount of information provided to the student before challenging them, so I'll demonstrate only one for brevity. Each of these pieces of content features a bar at the top stating the goal of the lesson, alongside a brief description. Here, we'll be testing the student's knowledge of basic Boolean assignation and logical operators. Below the introduction is a block of code demonstrating the concept at hand, with the notable addition of these prominent question mark indicators. Clicking on one populates an explanations panel on the far right, with an explicit description of what the code in question is carrying out and the motivation for doing so. We can either continue clicking these icons, or use the next and previous buttons. Some lines would benefit from additional context, and this is helpfully available by clicking on the Additional Details button. These content examples allow a student to move at their own pace, much like the animated examples, but whereas those outlined the exact state of a program's execution each step of the way, the PCEX example takes the first critical step in introducing the reasoning and justification behind written code. When a student runs out of material to review, or otherwise feels ready to proceed, we can revisit the top of the content to try our hand at the Challenge Me button. We move from instruction to construction, and the user is presented with a simple drag-and-drop fill-in-the-blank problem. Scrolling down, we find Step 7 empty and ready for our code, which block can be used to determine whether at least one of the three booleans evaluates to false. For demonstration purposes, let's select something incorrect first. A critical aspect of Python programming is its white space, and so the user is permitted to adjust the indentation level of the code they introduce. In this case, it's not necessary, and checking our selection, we can see that we are indeed wrong. Given the option to clear our selection or get a hint, let's first get a hint as to what went amiss. Clearly outlined for us, we must find the check that determines whether all variables are true and negate it. So let's try not A and B and C, check our answer, and we are correct. The execution output is displayed for us and shows exactly what we expect to see. There's another challenge though, and this time we must determine whether all three variables are equal. When a student finishes every challenge, the content is considered complete, and they're free to move on or continue reading. These PCEX examples serve as a guided introduction to program assembly, and introduce many of the tools necessary to translate theory into practice. I think that two-dimensional lists would make a good concept to cover with our next content type, which are simple questions. And I think so because oftentimes they reflect a stumbling block where notions like nesting and zero-based indexing combine in a way that's difficult for newcomers to grasp. But these questions are what they say on the tin. Some code and a question, with a blank space for the response. Students no longer receive methodical guidance or explanations as to the meaning of individual lines. That's left for them to determine. Now, I can see that the variables a and b are storing the values 11 and 12 respectively, which means that the result will be equal to 23. But let's get it wrong for fun, and we can see that there's no confusion about how we did. The correct answer is presented, and we can try again. And trying again one more time, you might notice that while the multidimensional array has stayed much the same, our accessions have changed slightly. Students are free to repeat the problem as many times as they'd like, and sometimes they'll undergo these small changes like this to extend their value a bit further and provide an additional challenge for the student. Closing out of here, though, we can see that the score on this previously incomplete challenge has updated to reflect our passing score. Next up for us are parsons problems, and we'll find an example pertaining to letter frequency here under dictionaries. Each parsons problem presents a deconstructed program that addresses the prompt and asks the user to construct the solution by dragging one line at a time from the left into the assembly area on the right. The student has to engage far more robustly with the Python language now, while retaining that gentle guidance from having each necessary line of code visible from the start. Here I need to construct a function that counts the frequency of each character in an input string, returning a dictionary with the frequencies of those letters. As I drag the blocks of code in, you can observe how the existing lines move to make way. As I finish up the initial ordering, I'll go back and tidy up, just making sure that all of my indentation is straightened out and correct. And submitting the problem, we can see that we did just fine. But what if things were out of order? Making some changes, we are met with an error clearly indicating where the issue occurs without giving away too much to the user. They must critically examine the code that they've produced and rectify any issues with the flow of the program's execution. When everything is taken care of, the expected output is shown, and the problem is considered complete. Finally, we'll go ahead and move on to the JSON processing topic for our most advanced and final problem that we'll be tackling today, those being coding problems. In this example, the student is prompted to generate entirely new code that will return the smallest substring s of some starting string, beginning with the index 0, that contains n occurrences of a supplied letter. A great step beyond what we've done so far. Outside of the problem description and perhaps a docstring or some comments, the user is left to fend for themselves and answer the question as best they can. I'll go ahead and cut ahead while I type in a solution, and upon submission, as with other problems, we are informed of whether or not we were correct. In this case, however, we get to see some of the test expressions and their results below as well. While I might have smiley faces across the board with my correct answer, let's go back and try making an adjustment and seeing what happens. Something natural that may occur. Maybe someone is unfamiliar with how slicing a list in Python already excludes the end index, and so they subtract 1 here. Resubmitting this incorrect answer, we can see that only 3 of 11 test cases are passed, and review explicitly what goes wrong with each of our test expressions. The student would need to think like a programmer, and diagnose not just syntactic errors, but go far more into nuanced logical errors within their code. With the help of the test expressions, though, they'll be on the right path in no time. Thank you very much for taking the time today to review some of the options available to Python educators through the Mastery Grid system. Please feel free to look in the description of this video for a demo link where you can try out some of the content for yourself. And if you have any questions, leave a comment and reach out, and we'd be happy to work with you to explore the benefits of using Mastery Grids.